Hey, AB Calculus, it's Mr. Canfield. Today we are finishing up chapter 28. So we're gonna do number 2 in 28 because we've only done one problem in chapter 28 so far. This was one problem. Now it's a bunch of problems. It's just, you know, numbers are convention. Okay. So we're doing the accumulation function, right? It says let big F equal 0 to x, the integral from 0 to x of f of t dt, where f is the function graph to the right. So this is f. And notice how it says f of x here. Don't get confused. Remember, this x is different than this x. It's kind of dumb, I know. Just deal with it. It's okay. Our final goal is to sketch the graph of big F. You know, if you want, you just draw the line. Stu, I sketched it. There it is, right there. Sorry, okay. So let's find a bunch of these things. If I want to find f0, big F of 0, wait a minute. Then I go to this integral and I plug in 0 here. So it's going from 0 to 0, going from 0 to 0, that's 0. What about big F of 2? Well, then that's going from 0 to 2 of this integral. That means the area from 0 to 2. That's from here to here. Might as well just find the area underneath this thing. Well, it's a circle cut in half, and then the half is cut in half. This is a quarter circle. So the area of this quarter circle is pi r squared divided by 4. Right, because it's cut down the middle. So the radius looks like it's 2. So that's when we square that, it's 4. So 4 pi divided by 4, this is pi, and so is this. You know, I may as well. I'm probably going to need a bunch of these other things. So let me just go through. I know that this is a 1 by 2. 1 times 2 times a half is 1. And then this is 2, because it's 2 squares. Then this is a half by 2, and then times a half. So the area here is a half. The area here is negative 1/2. And then this area down here looks like it's a mirror of this guy. The area down here is negative 1. All right, and then over here, I'm just looking to make sure it's not asking for f of 5, because I don't feel like finding the individual piece. I'd rather find just this big triangle here because it's 2 by 2, so it's a 4, and then divide and like multiply by half. So the area of this last bit is 2. Oh no, but it's underneath, so it's negative 2. Okay. So let's see. F of 2 go from 0 to 2 is pi. F of 4 go from 0 to 4. We add it all up, right? Pi plus pi, 2 pi. F of 6, so 2 pi plus negative 2, so 2 pi minus 2. All right, but what about f of negative 1? So what that would look like is that would be the integral from 0 to negative 1 of that stuff up there. Wait, but to go from 0 to negative 1, we don't do that. We go from negative 1 to 0, so I'd actually have to pull a negative out front, and now I can go from negative 1 to 0. So if I go from negative 1 to 0, I get 1. Times a negative, I get negative 1. What about f of negative 2? Same deal, right? It's really the opposite of going from negative 2 to 0. So basically, all these are just going to be the opposite of what they would be. So that would be 3 normally, but with a negative, it's going to be negative 3. Negative 3, oh, wait, these are going to cancel each other out, right? If 1 plus 2 plus a half minus a half, those cancel. So f of negative 3 is still negative 3. F of negative 4 is going to be negative 2. Yeah, right? Slow down, Canfield. So negative 4, we're going to go from negative 4 to 0, but we're going to pull out a negative because that's the only way to make it work. So 1, 3, cancel. 2, yeah, negative 2. Okay, so what we just did, if our goal is to sketch f of x, big F of x, this was a joke. I was kidding. Drawing a nice letter. It's not even that nice of a letter of f of x. No, that's not sketching it. Sketching it's going to be down here. So I know that big F of 0 is 0. That means at 0, I've got a y value of 0 for big F. Yoink. And then I know big F of 2. So if I go to 2, I have the point 2 comma pi. So it's 2 comma a little bit more than 3. 4 comma a little bit more than 6. 6 comma a little bit more than 6 minus 2, so a little bit more than 4. 4.28 if you want to, Okay, so I got those dots. F of -1 is -1, so -1, -1, -2, -3, -3, -3, -4, -2. I now have a bunch of y values. I'm not allowed to just connect them because I know more information than this. I know big F prime. Remember our theorem or our big idea, big F prime is equal to little f. So if I want big F prime of 4, I literally just want little f of 4, which is 0, right? The y value at 4. Big F prime of 2 is literally the y value at 2, which is 2. Big F of 6, -2. Big F of 5, -1. That's the y value there. So these tell me different slopes of big F. So like I know at 4, big F has a slope of 0. And I mean, that kind of matches. It looks like we have a max there. Then I know big F of 2, the slope is 2. Big F of 5, the slope is 8. So these are all checking out. All right, F double prime. Remember, like if we have big F, well then big F prime, so big F is equal to the integral of baby f, right? So big F prime is equal to baby f, and then big F double prime is equal to baby f prime. So big F double prime is literally just saying the slope of f, of baby f, at 2. So what's the slope of baby f at 2? 0. What's the slope of baby f at 5? Oh, it's that slope there. Looks like it's going down 2 over 2. Yep, so -1. What about at -0.5? Oh, at -0.5, it's this slope, right? Which is -2. Then what's the slope at 0? Oh, the slope of f at 0 is non-existent. It's undefined because it's a sharp point. So that means that when we go and we graph this in a little bit, this right here, it's not going to be smooth right here because we have an undefined slope. Where else do we have undefined slopes? We have an undefined slope at 4. So even though 4 is going to be a max, there's going to be some kind of undefinedness going on. So I am going to make some sign charts and figure stuff out. I'm kind of ignoring what Stu is doing. He's asking us good questions, but all right, let's see. So let's do an f prime chart. Remember, which this is just regular f of x, right? So let's see. I know at -4 it's 0. At -3 it's -2. Or I can just do sorry, I can just do sines, right? Dan, 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 dan. And then at negative 3.5, so let's see. So here's x, negative 4, and then negative, oh, that's 2.5, negative 2.5. We're at 0 again. And then at 0, then we're, little f has positive values all between there. And then little f has positive values all the way up until we hit 4. Where it's 0 again, and then after that it's negative. Okay, so what does this tell me about big F? Well, it tells me that big F is flat going down, flat going up, flat going up, flat going down. Or allegedly flat. And then we can do an F double prime analysis. Sorry, big F double prime analysis, remember, which is just little f. So, little f prime. So, little f prime has a DNE at negative 3. So we've got negative slopes, positive slopes, and then at negative 2, we've got another DNE. And then at negative 1, we have another DNE. And then at 0, we have another DNE. And then at 2, we have a slope of 0. And then at 4, we have another DNE. Okay, so between negative 2 and negative 1, our slope is 0. Between negative 1 and 0, our slope is negative. Between 0 and 2, our slope is positive. Between 2 and 4, our slope is negative. And then between 4 and the end, our slope is negative. So this tells me we have concave down, concave up, no concavity, concave down, concave up. Looks like we have an inflection point, right? Because it's going from concave up to concave down with an f double prime of 0 in the middle. Then, bam, and then more concave down. Okay, so let's see if we can't make this work. And then I'll go back and actually answer Stu's questions. So, goes down. Oh, okay, it goes down to negative 2.5, and he doesn't ask us what negative 2.5 is. I actually should find negative 2.5. Well, that's a half, right? So it's going to tack on another half here. Okay, so we're concave down up until we hit negative 3. And then we're concave up between negative 3 and negative 2. And I'm supposed to have like a disc, like a not nice smoothness there. So I've already kind of ruined it. No concavity between negative 2 and negative 1, so that should be a straight line. Then from negative 1 to 0, we are concave down again. And then from 0 to 2, we are concave up. And then from 2 to 4, we're concave down. And then we're concave down for the rest of it. All right, I wonder how far off I am from what Stu wants. Well, anyway, let's go and see these other questions. What subintervals of -4 to 6 is big F increasing and decreasing? Well, big F is increasing between -2.5 and 0, and then from 0 to 4. Big F is decreasing from -4 to -2.5, and from 4 to 6. And you know, we found that by using this sign chart. So a justification for this would be big F prime is less than 0 on those intervals. Big F prime is greater than 0 on those intervals. And I can explain more about that if you need that. Just let me know. Find the absolute minimum and maximum values of x on the interval. If I'm going to answer this question literally, the absolute value, or the absolute maximum of x is 6, and the absolute minimum value is -4. I think he means to say big F. So if we're going to find the absolute max of big F, we want to check our beginning and ending point. So our beginning point was 0. Our ending point was 4 point whatever. And then neither of those actually end up being our absolute max or min. After we graphed it, we saw that our absolute min occurred at -2.5, and the y value would have been -3.5. And then our absolute max occurs at 4, where our output value is 2 pi. And then concavity, we've already talked about that, and so there's our graph. And let me just really quick, while I have you here, and I make my chair get really creaky, let's just double check. Doesn't hurt to double check. Cool. Yep. So I actually went a little bit more detailed than he did. Yeah, sweet. Well, I hope this was helpful. Up next, we are going to be looking at, I think it's the fundamental theorem of calculus. No, Riemann sums. I think Riemann sums is next. So, cool. Well, hey, hope it was helpful. See you soon. Bye.